Alright, welcome to the first video on series circuits, and here we're going to be defining what a series circuit is and just some general rules that we use to work series circuits when we're doing our calculations. And so if we were to define a series circuit is any circuit that has only one path of current flow. So series circuit is a circuit that has only one path for current to flow. And we can see that singular path, or that one path, right here. And so just to kind of orient ourselves to the circuit, this is the battery, and so this is the symbology we're going to use for a battery here. These are resistors, and here we're given a variable R sub 1 and R sub 2, and so these would have two different values for these two different resistors. And the way we interpret the battery is that the short side, or the short line, is always going to be our negative side. Our long line is always going to be our positive side. And so using electron flow theory, electrons are always going to flow from negative to positive, and so our current flow, our path for current flow, is going to come out of the negative side, run through our circuit, around, back into our positive side. Now you may see different videos on YouTube or different illustrations in the book that show power running or electricity flowing from positive to negative, and they're just simply using a different type of theory called conventional flow theory. It doesn't really change anything. All it changes is our signs when we flip-flop back and forth, but none of the math or anything changes switching back and forth between conventional flow theory and electron flow theory. So back to current flow, this one path for current to flow, this is our one path for current to flow. And so this current flow, we're going to give it the variable I sub t, because that is going to be the total current flowing in the circuit. Again, we've already given a variable to resistance as R, and then the applied voltage is, in this case, coming from our battery, and we're going to give that the variable E sub t. And so as we're looking at circuits in general, in DC current, or in direct current or DC circuits, we're really only concerned with four variables, right? And depending upon where we're at in class, the first one is going to be E, and that's the variable we are using for voltage. And I know that seems a little odd to use E for a word that is beginning with V, but in science and math, sometimes we deal with velocities, and so V was already taken. Early on, E was the electromotive force, or voltage was considered to be the electromotive force, which is why we use E. Secondly, we use I, and again, this is going to be current, or the variable we use for current. Again, I for a letter, for a word that starts with C, seems kind of weird. It has to go all the way back to the French guy that found current or discovered current. In French, it started with an I, and so that's why we still use I today. No big deal, we just got to remember that I is used for current. R is going to be for resistance. And finally, we haven't drawn it yet or depicted it over in our circuit here, but P is going to be power. All right, and so if we look at these, we can start to intuitively understand some of the rules for series circuit. Let me zoom out just slightly here. And so if we look at I sub t, right, I sub t is this current flowing all the way through the circuit. Well, we interpret I sub t as all of the current that is coming out of the battery. If we look at all the current coming out of the battery and where it has to go into R sub 2 and then come out of R sub 2. And so if we were to look at the current running through R sub 2, we would say that it is equal to I sub t, because it only has one path for current to flow, right? And so if we start generating the rules here, so rules for series circuits. Again, we'll go over this in class. I wanted to create this video just in case you're doing some studying and wanted to revisit some of this, or if you didn't catch it in class, you at least had a place to come back to. So the first rule we see is that I sub t is going to be equal to the current, and if we follow the current flowing on around, we see that it is also the current flowing through R1 and then back into the battery. And so what we say is that the current total, the total amount of current coming out of the battery, is equal to the total amount of current flowing through resistor 1, and so we call that current I sub 1, and that's just going to be the current running through R sub 1. And it's also equal to I sub 2, or the current running through R sub 2, okay? And this would go so on and so forth. If we had additional resistors in the series circuit, it would just continue on. Regardless of the number of resistors that we had, IT would equal I1, would equal I2, would equal I3, so on and so forth, all right? So coming back to resistance. Now, the way I like to explain this is if I'm an electron coming out of the battery and I start running down this circuit, I'm going to meet R2 first. And so that resistance, I'm going to say, okay, that's the resistance in my path. So I met a little bit of resistance, and then I continue on my path, and then, oh, I met some more resistance. So by the time I get back to the battery, I'm telling all my electron friends, hey, if you go out there, you're going to meet some resistance initially. We're going to call that R2, and then again, you're going to meet some additional resistance. We'll call that R1. And so what we can say is that the total resistance in a series circuit is going to be equal to the first resistance we come into, or in this case, we'll just call it R1. I know I routed it through R2, but just to keep them in order, R1 plus R2, so on and so forth. And again, if there were more than 2 resistors in the circuit, let's say we had 3 or 4, it would just be RT equals R1 plus R2 plus R3 plus R4, so on and so forth, for however many resistors we have in the circuit. Well, voltage and power are a little bit harder to explain. So what we'll do is we start out with a certain amount of pressure. And so if we remember from the lecture, voltage can be considered like electrical pressure, right? So kind of like water flowing in a pipe, the pressure that is inside the water is just like the electrical pressure that we call voltage. As that pressure, as the fluid flows through the pipe, when it gets to a point, and in this case a resistor, in a water system you can think of it like a water wheel, the pressure is going to dissipate some of its force across whatever component. In electricity, it's very much the same, in that we're going to dissipate some of the electrical pressure through this resistor, and we're going to experience a voltage drop. And so here I'll say that this is, we'll just make up some, this is EA, and this point will be EB. And if we look, this is a conductor having negligible resistance, and so up here is also going to be EB, or the voltage, right? The potential is all going to be the same on this conductor. And by the time we get back here, this is EC. All right, so this is going to have a different potential than this, and this is going to have a different potential than this. because we have components in between these, right? So we have a straight line here, but we got a battery in between here and here, and so we can't have those as the same potential. There is going to be a potential difference. And remember, voltage is also called potential difference. And so it goes by all of these names, including electromotive force. And we have a resistor in between EA and EB, or this lined portion, this conductor and this conductor, and so these cannot have the same potential. And so any E that we have, let's say R1 for example, right? So the potential difference across R1 is going to be the higher potential minus the lower potential, depending upon how we measure it. And so in this case we will say, and I'll just write it over here so I can keep the rules consistent, that E1 is going to be EA minus EB. And so these are potentials, right? EC is a potential, EA is a potential, EB is a potential. When we say potential, what we mean is the potential to do electrical work, be it through a pump or through a motor or through generating heat. Any of those are doing work or dissipating power. And so this is the potential part of the potential difference, and the difference part is just the negative sign. And so it's the difference in these two potentials, all right? And then if we come down to here, we have E2, which is the voltage drop across E2. And again, we're going higher potential, since this is on the positive side of the battery relative to this, which is connected to the negative side. We're going to have EB minus EA. And I see that I've made a mistake up above here. This should be E sub C, and I apologize for that. And so E1 is E sub C, or this potential, minus this potential, and that's going to give us the voltage drop across E1. And then E2 is going to EB, blah, blah, blah. E2 is going to be EB minus EA. And so EB minus EA is going to give us the voltage drop across E2. And so if we added this voltage drop to this voltage drop, what do you think we would get? Well, we're going to get the total drop across the battery. We would get ET equals E sub C minus E sub A. And so the way we can better visualize this is that there's, imagine a staircase, and from the top of the staircase to the bottom of the staircase is the entire potential that we have to work with, right? So think about potential energy, height above the ground. Some object that is some certain height above the ground is going to have some potential energy due to gravity. And so up here, which is the top of the staircase, that potential is going to be, the potential up here is going to be ET. And if we look the next stair step down, this potential we'll say is, this is EC, the next stair step down. In between here, this is EB, the next point of potential, and then EA is going to be at the ground. And so we always consider our negatives to be ground, and if we looked at the ground, we would see that EA is at the ground level. EB is a little bit higher in potential, and so here's our EB, and then EC is at the highest point of potential. And so this drop right here, this voltage drop, would be E sub 1, and this voltage drop here would be E sub 2. And then we can see if we add E sub 2 to E sub 1, we get the total distance E sub t. And that brings us to our third rule, which is E sub t, or the total voltage, is going to be equal to E sub 1 plus E sub 2, so on and so forth, for all of the resistors that we might have in that series circuit. And so lastly, we have one additional variable to tend with, and that is going to be total power. Now, the first three rules, when we start talking about parallel circuits, the first three rules are going to differ between series and parallel circuits, and so we're going to have to memorize these for series, and then in a video or two later we're going to see some rules for parallel circuits, and we'll just have to memorize those. It's just one of the things we got to learn as we go through basic electricity to commit to memory. Luckily, total power is the same for series or parallel, and so if we were to look at the power dissipated by this resistor and the power dissipated by this resistor, and it dissipates power in the form of heat. So if we looked at the heat generated by this resistor and the heat generated by this resistor, how much heat does the entire circuit dissipate? Well, we would just say it's this heat plus this heat. And so we can mathematically show that as the power dissipated by resistor 1 and the power dissipated by resistor 2. And if we had additional resistors in there, it would just continue on, so on and so forth. And so P sub T equals P sub 1 minus P sub T equals P sub 1 plus P sub 2 plus P sub 3, so on and so forth, for all the resistors that we have in the circuit. So the takeaways here is that these are the rules for the series circuit, and we are going to use these extensively throughout the class in solving series circuits. These are the things you need to commit to memory. So if we're studying at home, this is what we need to be focused on, and this definition, right? A series circuit is a circuit that has only one path for current to flow. If you see multiple paths for current to flow, it is not a series circuit. All right?